Hi everyone, we're Foreflame and our project is Survive, sponsored by Microsoft. I'm Chen Ying with Monza, Teja, Gloria, and Iran is online. Our topic is about wildfire. Wildfire is a global issue which is not just limited to one or two countries. This effort happen again and again once the fire season comes every year. And it burns a lot of 2019, there's 92 million acres of land burned. And 2019, there is $1.59 billion spent on the suppression. And in the past 10 years, there are a lot of firefighters killed on duty. The flow shows the wildfire management pipeline, and in this pipeline, including pre-suppression before the fire, and also the suppression after the fire happens. And based on the environmental economics and management, a better fire management system with efficient tactical decisions can reduce up to 80% of kills on the suppression. And so based on that, we have a stakeholder like USDA, USFS, DNR, and also the wildfire researchers. And based on the research, we found their 10 points, including the segmented user group, lack of a unified system to collaborate together, and also the factors using the machine learning model which influencing the wildfire behavior do not update by time, and also different data sets does not integrate properly. And so our solution come up with an interdepartmental web-based application that can help fire analysts and managers to make risk-informed tactical decisions. So how we do this is to integrate comprehensive data into the machine learning model to predict the possibility of wildfire occurrence in the next 5 days in Washington state. So our main target user, the wildfire analyst, can use this dashboard to get the historical wildfire and also the prediction results, and share this analysis with the fire managers and other departments. And the feature of our product is we provide a prediction result that can support the fire analysts on their suppression strategy. And also we provide a dashboard visualization which can identify the fire prediction and also the location. And we hope this tool can be extendable to combine more roles to work in this platform in the future. And this is our approach. For the research part, we have a secondary research to know the field background and also our competitor. And we interview 6 experts in related fields. And we have an user observation with a forester working in USFS to know how they use the current tool and what it looks like. And we have a field study with the DNR team to see how they work on the fire prescription. And we categorize the findings from the research data with the affinity diagram and also use the cognitive walkthrough to find the pain points and also opportunity during this process. And then we move on the prototype design. We iterate 3 different prototypes and with 1 user evaluation. And for our department, we have 2 user evaluation and 1 functional evaluation with 3 participants.
We have done 6 expert interviews with researchers, forester, fire analyst, professor, meteorologist, and fire manager. We have also done a pre-script fire field study. In the remote user testing, we test people with Foreflame dashboard prototypes. In the second prototype, we have done it with 7 participants, namely lead meteorologist and role program manager, fire regulation program manager, fire analyst, volunteer disaster responder. In the third prototype, we have tested it with 4 participants, namely Imashu, Virga, April, and Roberta. From those researchers, we got 3 key insights. Bounding box and bookmark feature can help monitor an area of customized boundary. Better collaboration can be helpful, generating quick report and sharing. In weather data and fuel data require more consistency and great resolution.
So for the demo part, we'll be simulating. So for the demo part, we'll be simulating a real-time how a wildfire analyst would use our tool. So I'll be acting as the wildfire manager right now, and we assume the date is 25th of July because we see more fire occurrences in those months. So yeah, let's start the live demo. So if you go to our Foreflame website right now. So this is the dashboard we'll be greeted with. So I'm already logged in with my account right now. So I'll go ahead to the dashboard. So assuming the current date is 20th of July, our default date is set to 29th of July, which is like 5 days from now on. I should mind that my dashboard will only predict the next 5 days of fire occurrences. Right now, we have a lot of fire occurrences going on here, but I'll be only concentrating on Olympia because as a wildfire analyst, that's my jurisdiction. And I've also noticed that there have been some wildfire occurrences in that region. So I'll use the bookmarks feature to quickly go to Olympia. And if I zoom out a little bit, for the date of 29th, I can see that. So for the date of 29th, I can see that there have been some wildfire predictions, but I'm not too worried about it right now because the confidence is pretty less. It's just 30%. But just to be sure, I can also use this timeline feature to move back and look at different days. So for the date of 28th, I see that there are some predictions, and for 27th, yes, 26th, yes, and the 25th, which is today, there have been a lot of 5 predictions to the eastern region of Olympia. So I'll make a quick mental note that I have to translate these findings to my fire manager. So while I'm here, just to do a quick sanity check, I'll go ahead and display all days, which displays all the data for the next 5 days. And I can see that there's a lot of possibility of fire occurrences, especially to the eastern region, which makes it even more important that we have to convey this information to fire managers. If I'm curious about any particular point, I can zoom in and click at any one pixel, so I can get accurate results of what the precipitation, wind speed, all that values are. I can also take note of other parameters like average temperature, average wind speed, or the possibility of rainfall, which is synced to this report. So just to explore it a little more, I can see that especially near Mount Rainier region, there are a lot of fire occurrences. And if I go ahead and unselect my display always, and if I go to the day of 29, I can see that there are some predictions that are there are some possibility of wildfire occurrences here. But if I move back, there are not so many. But as the latest date is 29th, I'll have to keep note of this region for tomorrow and after tomorrow to see how this progresses for the next week. So I can go ahead and bookmark this region as well. So which is saved to my profile. So, and right now, as I'm not too sure about how the terrain of this looks like, I can also go ahead and select different themes and look at this in a 3D view so that I have a better idea of how the fire propagates. Because as a fire analyst, I know that especially in steeps and valleys, my fire can occur more and it can propagate more, so I can get a better understanding of how the fire may progress. So this is how I would use this dashboard, and then move back to the presentation right now.
So here is our software architecture of the system. The Asia VM requests the daily real-time data, including weather, NDVI, and view. And this inputs will be fed into the model we trained by the historical data. The outputs will be stored for the future validation and also front-end display. Our mainly visualization is supported by the map box through the GeoJSON data. And the dashboard is hosted by the React framework. Our final model is combined by the weather DNN and the vegetation KNN model to provide 5-day predictions. We utilize data from 2010 to 2022, 90% for training and 10% for validation. And generally, in our case, the precision is more important because we want to avoid the first alert. So the over 90% precision is good. Here are some comparing examples between the historical wildfire and the predictions in this year fire season. So like 25th, there are 7 fires occurred and 5 predicted, and similar in 26 and 29th. And we have 4 different prototypes. First one is on designed on the Figma, and the second one we based on the research surveys and interviews. We start the front end, and then we separate the login and start to link with the backend. And in the final one, we refine the login page and also the functions on the dashboard.
So Foreflame is a step forward in supporting fire management system. And here are our value propositions. We bring in unique data sets from different organizations, combine them using data fusion, and run an ML model to help fire analysts visualize all of this data. We've clustered the wildfire occurrence predictions into and provide them with confidence values that cross-validate the occurrences. We are expecting to run the model on FarmVibes AI, which is significantly faster, and our users can focus on specific regions of interest. The overall cost spent on average annually towards fire management is shown on the slide here, and annually in 2020, DNR spent about $8 million towards prevention, and prevention expenses include tools, technology, and research methods to improve their current understanding. Here are an overview of our customers. We are currently focusing on 5 federal departments who own more than 29% of land in Washington state, and other private owners as well. And to give you a scale of how fast wildfires are increasing in the United States, there are 24,000 wildfires that occurred in 2022 in the United States alone. Our key risk factor has been reliability throughout these 6 months. We've questioned different things, different aspects related to what the decisions made by fire analysts would lead to. And because the input data set, the model is heavily dependent on the input data set. And here's an overview of the next stage of development. Thank you. We'd like to thank all of our sponsors, mentors, and advisors. Thank you so much.
Foreflame team. Any comments or questions from our audience? Which seems to be growing.
Thank you. Amazing work with Pete. So I'm really commenting myself. And so one of the other aspects of this work is on sustainability. As you know, the impact of climate change and the role forests play. If you look at the business aspect of all of this work with respect to sustainability and how can companies or other organizations pay for keeping the forests still alive and preventing forest fires, and how much money is that? Did you get a chance to look at that?
We did get a chance to look at that, but we did not narrow down on a particular amount. During our business pitch, we presented that it would cost around $1 million per year for our organization, but that's a very rough amount that we as students researched about. But I think there's a lot going on because of research and development that needs to be done in the field.
And did you also look at the lumber industry? That's pretty big as well.
Yeah, the private.
Is it?
Yes. Thank you so much for being here.
Thanks.
Other comments or questions?
Very cool project. The precision of your model was really impressive. But most of the time when you hear about a forest fire, it's like a random event where it's like a down power line or like a gender reveal party. So but it looks like your model just doesn't take that into account, but still has that really high precision. Are you assuming that the stupidity of humanity is consistent and it's the weather that is really the defining factor about whether or not a little campfire will grow?
So it does depend, according to our research, a lot on the weather parameters and the fuel, how it will grow and where it might occur, right? So if it's wet and humid, it wouldn't likely occur in that location. So because we trained it over a period of 10 years, and try to test it on multiple occasions. There might be false negative, like false positives occasionally, but currently we run our model on a month of data and predict it for 5 days. And for the 5 days, our precision is really high.
Cool. Thanks.
Yeah, thank you so much.